cosine of x plus root 3 equals 0. And we're solving from 0 to 4 pi. I'm doing part A first. We'll come back and do B. All right, so just like we solve any equation, we isolate the variable. We isolate the variable. So let's isolate the variable. Who's doing fine in my class? Cosine of x equals negative root 3 over 2. Negative root 3 over 2. So now just ask yourself. This just goes back to knowing the unit circle. That's it. That's why I said from day one, you got to know it. What angle goes here that gives me a cosine of negative root 3 over 2? There are two angles. Everybody must know this. 120 is not right. 30 is not right. 150 is right, except it needs to be in radians. Yes. And? Yes. Take lessons from Josue. Questions on how we did that? Questions on how we did that? Now, unfortunately, this is not all of the answer. The reason this is not all of the answer is because they want us to find answers from 0 all the way to 4 pi. Our answers came from the unit circle. And the unit circle only goes from 0 to 2 pi. So we got to see what is happening from 2 pi to 4 pi. We need to get some more answers. How do I find the other answers? Eddie? Yeah, which one? Pi? Why pi? Why 2 pi? Think about it. Folks, which one should we add? If you look at the cosine graph, if I'm here and I add pi, do I end up at the same spot? No, I need to add 2 pi. Why? Because 2 pi is the period of cosine. So for cosine and sine, anytime you add 2 pi, you get back to the same spot on the unit circle. This is why for negative angles, we always add 2 pi. A 0-degree dunk is the same as a 360-degree dunk. You're facing the same way. Anytime you add 2 pi, you don't change anything. Why 2 pi? Because 2 pi is the period for cosine. So we need to add 2 pi to find the next solution, because there are 2 more solutions. Add 2 pi over 1, get a common denominator. So for part A, there are not 1, not 2, not 3, but 4 solutions. Why 4? Because we're going from 0 to 4 pi, and from 0 to 2 pi there were 2 solutions. So if you double the amount of distance, you must double the number of solutions. This is the whole point of a periodic function. It just repeats over and over and over again. Four solutions. You need to write all 4. Questions before we go on? I'm about to do B. This is not easy. This This is not easy.
What is that, 19?
19. Alrighty. So we've got these four solutions. Why four? Because we're going from 0 to 4 pi. Between 0 and 2 pi, we had two solutions. So between 2 pi and 4 pi, we also have two solutions. So in total, from 0 to 4 pi, we have four solutions. Now let's see what happens on part B. Part B says do the same thing. It's the same equation. So 2 cosine of x plus root 3 equals 0. And part B is negative infinity to infinity. Part B is negative infinity to infinity. So, we're going to solve this problem the exact same way we just did. So let me resolve exactly what I did. So again, we want to isolate the variable. We want to isolate x. So, step 1, let's minus the root 3 on both sides. 2 cosine of x equals negative root 3. Divide by 2. This goes away. Cosine of x equals negative root 3 over 2. Where is cosine equal to negative root 3 over 2? Well, as we just said, 5 pi over 6, 7 pi over 6. So that's the basics. But we have to go from negative infinity to infinity. These would be the answers if this said from 0 to 2 pi. But we are going from negative infinity to infinity. From negative infinity to infinity. So what do we need to do? Well, if you think about this logically, if I'm going all the way to positive infinity, that means there must be infinite solutions. This thing keeps repeating. The cosine graph keeps repeating, and I'm going all the way to infinity. If you look at this graph, think about this graph, we didn't ask Mariah to keep drawing this, but had we asked Mariah to draw it to infinity, she would still be drawing. There'll be infinite solutions on either side. So, there must be a better way to write this than to sit there and write every single solution by hand. And in fact, there is a better way to write this. Here's what we do. We say the answer is 5 pi over 6 plus 2 pi k. And I'll explain what this means in a second. But please make sure you get this down. And then you have to write where k is any integer. Where k is any integer. So what does this mean? What does this mean? Well, it means the following. We know that one of the solutions is 5 pi over 6. We know that another solution is 17 pi over 6. We got that in the previous problem. There'll be another solution if you add 2 pi again. There'll be another solution if you add 2 pi after that, and add 2 pi after that, and add 2 pi after that. You can keep adding 2 pi, and you'll keep getting more and more solutions. In fact, we want to keep adding 2 pi infinite times. So rather than writing by hand, let's add 2 pi once, then let's add it twice, then 3 times, then 4 times, and 5 times. We just say, let's add 2 pi k times, where k can be any number. K could be 1, it could be 2, it could be 3, it could be 4, it could be a million. So instead of doing it by hand 20 times, we're just saying let k be any number and any integer. So it could be positive or negative. The negative takes care of this, the positive takes care of this. And where did the 2 pi come from? The 2 pi came from because 2 pi is the period of the cosine function. If this was asking about tangent, we would have written pi here, because the period for tangent is pi. If this was asking about cosine of 2x, what is the period of this? Well, the period is 2 pi divided by b.
What is b? b is 2. So the period is pi. So if it had been this, we would have added pi k. If it had been cosine of 10x, what's the period of this? 2 pi divided by 10, pi over 5. It would have been plus pi over 5k, whatever the period is. Questions? Questions? Okay. Let's finish up with number 12. Finish up with number 12. So number 12 says, solve the equation 2 cosine of x sine of x equals root 3 cos x. What I'm about to do is wrong, and I'm doing it so that you all do not do it. Many people might be tempted to do what I'm about to do. This is wrong, what I'm about to do. Many people are tempted to do this. They're like, oh, I see there's a cosine of x on both sides, let's just divide by it. And they're like, oh, this is a super easy problem, very similar to what we just solved. The reason why this is not good, and in fact this is wrong, is cosine of x could be equal to 0. Cosine of x equals 0 when x is pi over 2, 3 pi over 2, 5 pi over 2, negative 3 pi over 2, negative pi over 2, and so on and so on. If we know that cosine of x could be a 0, we can't divide by 0. Hence, you are not allowed to divide by these trig functions. You can't divide by cosine, you can't divide by sine, you can't divide by tangent, you cannot divide by trig functions. Do not do this. We need to solve this problem a different way. So how should we solve it? Well, let's find out. The way we should solve this is the following. What we should do is, instead of dividing, just minus this on both sides. Minus this on both sides. Minus on both sides. This goes away. We'll bring it over here. And here's what we'll get. Here we are. And now I notice now it's just pure algebra. I see cosine in both terms, so I'm going to factor out the cosine. Factoring out is essentially the opposite of distributive property. Distributive is you take a number outside and multiply it by both. Here you take a number inside and basically divide it out. So you have cosine of x, 2 sine x minus root 3 equals 0. Why does this work? Because if I distribute this, if I do cosine of x times 2 sine of x, what do I get? 2 cosine x sine x. If I do cosine of x times negative root 3, what do I get? Negative root 3 cosine of x. So let's finish up here. Now, two things, two factors multiplied together equals 0. Zero product property. That's going to be like your best friend on all these equations.